Okay, so the Z590 Dark is running now. So the overall setup looks pretty much the same as you have often seen on my YouTube channel. But this time around we do have some RGB lights on the Dark. That's something completely new. I think you can change those colors with the ELED X1 software inside the operating system, but I haven't tried that at all. The overall setup is, I think it's pretty similar to the one most of you will be looking for if you are going to purchase this motherboard. So we have an 8-core Rocket Lake CPU, no matter if it's 11900K or the KF. We have 2 sticks of high performance dual rank Samsung BDI based memory. So these are the G-Skill Ripsource 5 4266Cas17 sticks with custom heatsinks. I think most of you will be getting 32 gigabytes of memory or even 64 gigabytes of memory nowadays, because 2 times 8, so 16, is quite a low amount nowadays if you are going to do any kind of like video rendering or similar workstation use. For a basic like gaming system, even 16 gigabytes can be just fine, but I think most of the gamers out there will be getting like 32 gigabytes of memory nowadays, I think. Only missing a high performance GPU like the 3090 Kimpin, but just using a simple VGA to display the monitor signal for this demonstration video right now. The only minus what I found out was the bottom PCI Express slot, and this was actually pointed out by Tin, a former EVGA employee. So the battery is located in a quite difficult spot, so the edges of the battery thingy, they are going to touch the golden teeth of the PCI Express device. So if you are trying to install like an X16 PCI Express device like that VGA over there, it will hit the edges of the battery thingy. So you cannot install an X16 PCI Express device onto the bottom slot. So that's a minus. So well, you can still install like a sound card or a similar like X4 device or similar to the bottom slot, but I don't know. I don't think it makes that much of a difference for the widest audience. But yeah, so now I will move on to the capture card. Let's go through the BIOS, see all of the different features, and let's see how you can actually overclock the CPU and the memories with this particular Z590 motherboard. Okay, so this is pretty much how the BIOS welcome screen looks like, so pretty much the same as before. So on the Z390 Dark, Z490 Dark Kimpin and so on. So let's enter the setup by selecting the advanced configuration over here. So yeah, pretty much the same as before. The BIOS version is the latest retail one you can find from the EVGA downloads section. So version 1.05, date is 16th of August this year. So running the same 11900K that you have already seen like 2 times on my channel already. So there's pretty much no difference over here. So OC, memory, advanced and so on. So if you select the OC tab and then left arrow key once, you can highlight the extras and then go down to OC profiles. There are a few profiles made by Kimpin and me, like benching profiles with Gear 1. Then there's for like Geekbench 3. Gear 1 is definitely like suited for like SuperPi and so on. One daily profile for dual ranks by Kimpin. One high frequency dual rank profile for Geekbench 3 by Kimpin, and a few daily profiles by me. The 4800 A2 PCB dual rank 1919 is the one you already saw in my video like in July. So let's load that one. Let's load that one now. So it has a CPU overclock of 5.2 GHz across all of the 8 cores. For daily use, you want to use the AVX ratio offsets like AVX2. Good value over here is between like 1 to 3. I think 2 is good, and AVX 512 uses even more power than AVX1 or AVX2. So here a good value is from like 2 to even 5, but I think 3 to 4 is generally good. It really depends on how high you want to go for like non-AVX situations, like in terms of clock speed and voltage. So far, when like testing these CPUs, they don't seem to have that much difference, at least in my opinion, compared to like previous CPUs. Many of these CPUs can do like 5 GHz, 5.1, even 5.2. on water. So the difference between the worst and the best chip is lower, at least on water, but on like sub-zero cooling, that can change, or that can differ a lot more. Now for like simple testing, I always recommend you do like manual ratio limit first. So this uses like a flat multiplier across all of the available cores. Then if you want to fine tune, like get a higher average overclock, you can switch on the per core function. So if some of the cores are better than the other ones, like usually the first two cores are, at least on my two CPUs, they run cooler than some of the other cores. So I can do, let's say, like 53, like 5.3 on the first two, then 5.2, 5.2, 5.2, and like 5.3 on the second last core, which again is usually running quite a lot cooler than the other cores, and then 5.2. So this would have like an average overclock of like 5.23, between 5.23 and 5.24 on the whole CPU. There's one thing I want to point out about this thing. So if you go for the per core thing, do not change the vCore to per core, because there's a bug. Well, it's almost like a bug, but it seems to be like a feature from Intel side, that no matter what voltage you set over here, like per core, it will always load the highest available voltage. So that means it will run the voltage, the CPU vCore, well above 1.5 volts. No matter if you even set like 1.3 or 1.35 here, it will still load a very high vCore. So it's not something you want at all. Like considering, just consider running AVX based workloads at 1.5 plus. It's an enormous amount of heat. So per core overclocking works just fine if you stick to override vCore. And there's a problem with the ELED X1 software regarding that, because if you try to do like per core adjustments in ELED X1, it will revert the voltage mode from manual override to per core, and then again the vCore jumps all over the place to very high values, which we don't want to see. But now for starters, I will just do 52, 45, and for my testing I will put 0 and 0 on the AVX negative offsets. And let's look now. So 1.45 volts on the vCore. The VID of this CPU was like 0.94 something, like 0.946, but it varies all over the place. And I think VID values aren't really comparable between different motherboard models. They vary sometimes a little bit from model to model. When it comes to load line calibration settings, the most accurate voltage under load comes with the -25% less droop option, but that's socket sense measurement. So if you measure the vCore from the Pro PIC connectors, the vCore should be the pin that's the most left of the available ones. I think there's some mismatch on the PCB markings, because there's no vCore mentioned on the Pro PIC legend, but the pin on the furthest left is or should be vCore measurement. So -50% small droop works really fine as well. You can use it and should be just fine. It doesn't do that much overshoot. I think the overshoot measured at the socket level should be like 30 to 40 millivolts. So if you put in, let's say, 1.35, it will be from 1.38, 1.39 under load this time around. vCore PWM frequency, this will have next to no difference at all. I mean, in the actual like stability. So the VRM is very overbuilt, so you will not pretty much gain anything from setting the switching frequency at 300 compared to like 800, but it's set at the maximum value already by default. Now there was like a difference between the engineering sample model and the retail board. I have asked for the EVGA guys to change this, but you don't need a value on the normal VCCIO pretty much. So for very high memory clock speeds, even with Gear 2, you need to set the system agent voltage, so that's the VSA or system agent voltage, and the VCCIO 2 or the VCCIO auxiliary voltage. This is the VCCIO of the IMC on these Rocket Lake CPUs. So something like 1.4 or 1.45 on these should be just fine. Rest can be left at auto. Then here on the memory, plus 25 DIMM VTT did actually help quite a bit on the engineering sample version, as these profiles were made on the engineering sample one. But for some reason I'm having issues with plus 25 now on this retail board. So I have asked again for the EVGA guys to change this to just 0. So 4800, the DIMM voltage will depend on your kit. Some kit might need some kit might like 1.45, some kit might like 1.5 or 1.55, but usually anything higher than 1.6 results in a worse outcome than what it can actually help, because Samsung BDI based memories will lose stability if you go too high on the voltage. So you can run those high voltages with high clock speeds and low latencies, but you can only do that if you limit the maximum memory in like MS config in the operating system. So if you drop the maximum memory from, let's say, 32 gigs down to 4 gigs, then you can run like even 2 volts on the memory. So I have set 1.53 in this profile. Sadly no CAS 18, at least on my kit and IMC. I can boot I think 19 and 18, but so far 19 and 19 was fully like HCI memtest stable in my testing with these with this very same CPU and this very same memory kit. But you have to test it. You have to test this out yourself. Like whenever you do like serious memory overclocking, even for like daily use, you need to test the entire capacity of the memory you have installed. I have showed the HCI memtest numerous times already on my channel. So it's not enough to run something like SuperPi 32M or HyperPi 32M. You need to do something that will stress the whole capacity of the memory you have installed, no matter if it's 16 gigs, 32 gigabytes, 64 gigabytes, 128 gigabytes. Because if you don't test the entire capacity, you might be stable at something that only uses like half of your memory. But if you then use or if you go on some heavier workload, like you do multitasking where the memory usage goes up near the maximum amount of your whole memory that you have installed, and then it crashes, programs start crashing and so on, and you don't want that to happen, obviously. So that's why you need to use something like HCI memtest or like run memtest pro or similar program like that. But this is the timing table of the 4800 CAS 19 profile, so definitely check it. Definitely try this if you have a very good like dual rank Samsung BDI kit. Now advanced, here you don't really have to touch many things. If you want to use the Debug LED monitoring device, just go to the hardware monitor configuration over here, and here you can choose if you want to run the debug port the normal way around or the other way around, like turned upside down. If you have let's say the motherboard turned upside down in your case, then you can change the orientation of the Debug LED monitoring device. But now I will change the monitoring for CPU vCore. Other thing I could monitor is the PWM temperature, but vCore is alright. And this time around, this is actually die sense. So remember, this is die sense measurement. So you will see, even with the higher load line calibration options, you will see some kind of voltage drop. So even with minus 50% small droop option, it's likely that you will see like 20 millivolt or 30 millivolt voltage drop under load. So you need to remember the difference between socket sense and die sense. Socket sense is measured at the motherboard level just before the CPU, and die sense is measured directly from the CPU. So that's pretty much it. And UEFI, you need to select legacy if you want to run Windows 7 or similar operating system like Windows XP or Server 2003. So these are pretty much the settings now, or for now. When it comes to CAS, so before I save and exit, many of these Rocket Lake CPUs cannot run as high cache speeds as the previous CPUs, like the 10th gen CPUs. So with 10900K we could run like cache up to 5.2 or even 5.3, but now even 4.5 is too high for many CPUs. This particular CPU hangs like 4.7 at like 1.45 volts. The maximum is somewhere between 4.5 and 4.6, but you can start at like 43. A good start point for like testing out your CPU, especially if you don't run the strongest water cooling, you can start at like 4.9 or 4.8 at like 1.2, 1.25 volts. But these CPUs can take a lot higher vCore values because the die is larger. But yeah, so I'll set 5.2 and 4.5, 1.45 volts, minus 50%. F10, save and exit. Okay, so it actually refused to post with only 1.4 volts on the system agent and on the VCCIO auxiliary voltage. So I had to raise those back up to 1.45. So that's why I actually set those values in the profile. But now we are running 4800 CAS19 on the memory and 5.2 across all of the 8 cores, 16 threads, 4.5 on the cache, and 4800, 1990, 36, 360 command rate 1, BIOS 1.05. So let me show you. So this was 1.45 volts, minus 50%. So sadly, the CPU-Z voltage measurements do not work on these EVGA boards, at least on the mainstream ones. So the only like software that can monitor the vCore value to some degree quite well is ELED X1. So let me show you. And I also want to show you where the issue lies in the per core thingy. So now we can see 1.45, 1.432. And let me show you. I think this should be die sense measurement. So let's start the test. 1.43, 1.42. So there was like a droop of 12 millivolts. And you can't see it, of course, but the Debug LED monitoring device is also reading 1.42. So this is a die sense vCore measurement. So, and we passed 2682 points in R15, and temperatures are between 67 and 77. So it's actually pretty much the same on many CPUs that I've tried. The first 2 cores as well as the second last core, they are usually a bit better than what the rest of the cores are. So you can usually hit like 1 notch higher multiplier on these coolest cores compared to like the core number 4. Well, this is the 4th core technically, because the first core is 0, not 1. So it's likely that if we set let's say like 5.3 on this particular core over here, it's going to crash compared to if we set 5.3 over here. So let's see if I can actually do this like this way around. So what I will do is let's say if I want to move straight to per core overclocking like inside the OS. So let's see if we put like 5.3 on the first 2 and 5.3 on the second last core. Now look what happens. The vCore measurement on the package part was 1.43 at idle. If I set this, now we have 5.3 on these 2 cores and 5.3 over here. But if we go back to package, look, vCore has instantly gone over 1.5 volts. This is the thing I was talking to you about. This is, as I discussed with Kimpin, this is more like a feature from Intel's side. So that's why you should stay away from the per core thingy on ELED X1 and per core voltage inside the BIOS. You don't want to run this. Well, you can run this, but the temperatures will go very high immediately. Just as a demonstration, like a quick demonstration, I'll show it to you guys. So let's open up package over here. Look, did you see the vCore? 1.56. As this CPU has already been tested, I can show it to you guys. 86, 90. So you can see it's very high. So if you were running like a very simple AIO or air cooler, you would have hit 100 degrees very quickly. Luckily, these CPUs can stand voltage a lot better than the previous CPUs, like previous CPU generations, but we don't want this to happen. I'm sure you get the idea. I have told about this thing to the EVGA guys, and they are thinking about like a solution. We want to be able to do like per core overclocking, as we want to go higher than, or we want to do more fine-tune like adjustments than in 100 megahertz steps. Like at the moment we are running 5.3, 5.2, 5.2, 5.2, 5.2, 5.3, so the average should be like 5.230. You can get to 5.230 by raising the base clock, but many people don't want to touch the base clock because that will also affect the memory, and it can make the memory unstable. I'm sure you know this already. So now I will just reboot, and I'll run this again and show how I would do it myself. Okay, so let's enter the BIOS again, and let's change the CPU multiply control to per core. So before you go to per core overclocking, check which of the cores are running the coolest, like lowest temperature in different workloads. But usually, at least for me, as I already said, they have been the first two cores and the second last core. So I will put now 5.3, 5.3, 5.2, 5.2, 5.2, 5.2, 5.3, and 5.2, 4.5. Again, for daily use, keep these AVX negative offsets, like maybe 2 and maybe 3 or 4. But for my testing, I will put these to 0 for now. And again, do not change to per core voltage. That will cause the voltage to go up a lot. Again, doesn't matter what voltage do you set. It will go up to 1.55. I think it could, the measured voltage under load had been like even close to 1.6 in that example. And it doesn't go lower even if you set like 1.35 or 1.3 in the operating system in Elite X1, or even in the BIOS. It will still go to very high values. So it's a bit messy feature from Intel's side. So 1.45, same voltage, now just per core overclocking. Same memory, pretty much. F10, save and exit. Okay, so now we are back in the operating system. Open CPU Z and core temp. And I will open Benchmade for the actual test. I will open R15. Well, I guess most of you are already using R20 nowadays, but remember, R20 does use a tiny bit of AVX. So if you have any negative offset for AVX workloads, that will trigger at least on some of the cores in R20. So Elite X1 to check the voltage. 5.3, 5.3, and 5.3. Rest of the cores are at 5.2. And look, 1.43 volts. It didn't go up because we are still running a manual override CPU voltage. So let's fire this up. Temperatures are just like how they should be. 70, 70, 73, 78, 74. Seems to work, or seems to run just fine, but these cores have gone up because we are running a higher clock on them. When you increase the CPU clock speed, it will increase the amount of current it draws. So it's not, the power consumption of a CPU is not only about voltage. You can try this by lowering the CPU to a very low clock speed, like running the same test at same voltage at like 2 gigahertz. You can see that the CPU runs at much cooler temperatures. So making the CPU hot or warmer is not only about increasing the voltage. Of course, that has the biggest impact on temperatures and the overall power consumption, but also raising the actual CPU clock speed will also increase the amount of current that it draws, and at the same time the total power consumption. But this was stable, score 2700 points. Now I want to show you R20. Can we run R20, and is it stable, and what kind of temperatures do we see? 1.43 over here. Let's see when it goes under load. 1.42, 1.417. The temperature difference isn't that big, even though this should use some bit of AVX. No throttling at all on the CPU because we are not running any negative offset. but again, for like daily systems, you will encounter like workloads and applications that will use AVX to some degree, like rendering programs and so on. For those situations, you obviously want a lower clock speed so that you don't crash. So let's see what the score is. 6540. I think it's pretty good. So I want to still go back to the BIOS and try to increase a little bit more. Like, can we squeeze any more from this particular 11900K? But I think it's already pretty good. And the temperatures aren't too bad. But of course, if this was a 10900K, this would be a bit too high VCore value already. But it's fine on Rocket Lake. Okay, let's try this briefly. So this is 5.4 on the second last core, which was the coolest running core, and I also put this core up to 5.3. Of course, this is not like a test that you could call like or that would like qualify a daily stable CPU. This is just like a basic workload to give you some rough idea how to overclock these CPUs. When you want to confirm like a daily capable overclock, you need to run something like Prime 95 for at least 30 minutes or preferably a few hours. You can do like non-AVX or AVX1 based Prime 95 or AVX2 based Prime 95. There are quite a few options. So let's try to run this, but it might crash. Same voltage. Okay, I think it's the second last core is the issue over here. So we cannot set 5.4 on that. Okay, one more attempt. Now I came back to 5.3 on the second last core, and second core or the last core is at 5.3 and the third core at 5.3. Open Benchmate. 15 first. Still 68, 74. But of course this is more about like fine tuning. So you could do the same end result with and we crashed. It's either the last core or the third core. I bet it's the third core. It was at 76 degrees. And okay, so we passed at I don't know what's the average now, but yeah, 5.3 on half of the cores and 5.2 on half of the cores. So this core could have a chance on running 5.3 as well. So this is the fifth core. But now I still want to try R20. But this is pretty much like the end, and it's also very likely that this cannot run like non-AVX fully stable. So if you try to run, let's say, like non-AVX Prime 95 for 1 hour, it's quite likely that it can actually crash. So let's try R20. Okay, 6583. So this is like a step now that I could try to like aim for non-AVX stability. So what I might actually try now is changing the Debug LED monitoring device to VRM temperature measurements and try to run something like Prime 95 non-AVX, the latest version, for like 30 minutes or so, see where the VRM temperatures actually go to, as there's not that much airflow on that board right now, so just my standard fans, but they are not being set at like maximum speed like manually in the BIOS. So when talking about like overclocking, of course, this is more or less like fine-tuned adjustments. This is very like these are very like baby steps compared to like real 100 megahertz increments. So when you are going from like 4.8 to 4.9, from 5.0 to 5.2, so this is more or less like 10 to 20 megahertz increments. So they are very tiny in the end. But yeah, but I really want to try. So I'll change the monitoring device and let's see how the Prime 95 looks like. Okay, so I will try to run small FFTs, so the same test I have used for those thermal-based tests. So, and I have also disabled all of the AVX instruction sets, so AVX1, AVX2, AVX512. And you can monitor the PWM temperature in the monitoring part of the ELED X1. So let's fire this up. Should be pretty much like R20 in temperature wise, but of course it will just last a longer time period. 5.3 on the first two and the last two cores, and VRM temperature is going up, but not as fast as I thought. And in the overclocking part we can still confirm the V core, same as it should be. I think measured under load at the socket level would be like 1.48 at the moment. I could check it with the multimeter, but I think die sense is more important than socket sense measurement. 320 watt power consumption, 37 degrees, but of course it will be interesting to check it out after. So we started it at 2020. If we let this to run like 30 minutes, is it still stable, and how warm does the PWM temperature look like? So I'll let this to run and I'll come back to you after a while. Okay, so the Prime 95 has been running for 30 minutes now. So if we look at the Debug LED monitoring device, look at this, 47 degrees only. I could definitely make a bet that this is the best performing like VRM cooling solution on any Z590 motherboard, like out of the box. So it's performing really well. Now if we I'll use the camera instead of the capture card, you can see, you can read the same temperature over there. So PWM temperature 47, CPU temperature same as the hottest core, so 83, and not sure what the sys temperature is. Prime 95 still running, same clock speed, so 5353 and 5353 on the last two, and core temperatures themselves are like close to 80. So and look, 330 watt power consumption measured by core temp. So yeah, that's pretty damn rough. I don't think there's like any more room to go higher on the actual load on this same CPU, like in terms of power consumption, because it doesn't matter even if I go lower on clock speed and voltage, and even if it uses AVX, it should result in roughly the same like outcome, like power wise and temperature wise. So not sure like what's the maximum like theoretical power consumption you can realistically do in a long-term workload like this, just for water cooling with the Rocket Lake CPUs. But yeah, so that's not even passing 50 degrees. That's absolutely insane if you ask me. So definitely the best heatsink I have ever seen on any mainstream motherboard. So not sure how well that compares to other motherboard models, but it's definitely awesome. Actually, let's try to touch it. So over here, it feels a bit warm, but it's not like hot. Of course, there is some airflow, but those are like that fan and that one. That's running somewhere around like 2000 RPM. So yes, there is some airflow, but yeah, it really depends on what or how do you want to compare it, because if it's installed in a case, you surely have at least some kind of airflow around the board. So actually, let's try this. I'll take off the fan. I'll let it to run a tiny bit longer and see does it ramp up any warmer. So still 47. Okay, and after like 45 minutes it actually blue screened, so I switched the last core pack to 5.2. so the three coolest cores are running 5.3 and the rest 5 at 5.2, and I think this should be stable like how I thought already at the start. But now I have kept the fan disabled that blows like over the CPU socket area and the memories, and well, the difference isn't that big, like 6 degrees or so. So without a fan, now it's mostly with the tiny heatsink fans, just 53 degrees or so. And just to confirm for you guys, so here 53 on the PWM temperature, CPU temperature 82 and 29 sys, but I don't know where the sys temperature measurement is, and here is the difference. So 5.3, 5.3, and second last 5.3. The last core is now at 5.2 because the clock speeds have been decided based on those like individual core temperatures. Like the second last core is only 71 max. Last core was 79, first core 79, second core 75, so the most stable cores seem to be like the second core and the second last core, but I think the first core is quite strong on this chip. But yeah, so that's it for the CPU. So this could be like my daily like aim. So this is the non-AVX daily overclock, then just come back down with the AVX negative offsets, like 2 to 3 for AVX and AVX2, and maybe 3 to 4 on the AVX 512. Although AVX 512 applications are quite rare, especially for normal consumers. Like normal folks don't really use that many AVX 512 applications. But yeah, so that's pretty much it. Definitely great VRM like design and heatsink design overall. Okay, so it's pretty difficult to go any higher than this on the memory. I think 1818 could be like possible, at least in theory, but the next step frequency wise from this would be 5000. These multipliers that are marked with the asterisk, they are the non-working ones. So Rocket Lake is weaker in this regard than the Common Lake CPU. So many of the memory multipliers don't really work that well. Like over here, note odd ratio mark as asterisk. It may difficult to boot. Yeah, that's not written in very well, like in very good English, but you can actually try it. Like 1919, but it's trust me, it's not going to work. F10. Okay, so both the 4900 and 4933 just give like 1A or 11 debug codes, so they are not going to work. I don't know about the CAS 18 and CAS 18. I'm pretty sure I was able to post 19 and 18, but 18, I think it could be IMC limitation as well, so we could try like 1.5. Let's try this out, but I think it's going to fail. Yep, so the 4800 CAS 19 is pretty much the limit, at least on most of these CPUs. So 5000 is definitely a no-go with dual rank Samsung BDIs. It just gives like a 2B debug code. I tried very high vCore as well as very high like system agent and VCCIO auxiliary voltage, but it didn't really help that much. So from the profile, things you can improve are then mainly the timings. Like I was able to take down the TRCD and TRP down to 18, and then you can obviously tune the sub timings, but those are kind of like minor adjustments in the end. So I think if your IMC and kit are capable of doing the profile, then the profile should be very good already in itself. But just play around with the dim VTT. Some kits like purely like 0 on that point, on that value, and some kits might like some adjustments like plus 20, plus 30, plus 15, or even minus 50. That's a voltage you can play with. But if you really go like serious on memory overclocking, you need to test the entire capacity of the memory you have installed, like I stressed heavily at the start of this video. So here we can see 2.2 gigabytes are being used out of 32 gigs. So it's not enough if we run like a memory test that only uses like 700 megabytes of memory. We need to stress the entire capacity of the memory being installed. One funny thing though, when I was running the Pro 95, it actually did heat up the memories quite a bit. So the memory sticks themselves went up to like plus 40 or even plus 50. But luckily my custom heatsinks are quite good. They are the copper heatsinks from BIOS, but they match the color of the Z590 Dark's heatsink assembly very well. But yeah, so I still use the free version of HCI memtest, but as this is a free version, the maximum amount of memory per execution is like 3300 megabytes. You can purchase this or run something like the memtest Pro, or how's it called. So I haven't actually tested 1918 fully in this test, but the 1990 was fully stable, I think up to like 200% on each of the executions. So let's open up some of these. Oh, so 3300, 3300. Oh, then it goes. If you get that error pop-up screen, you just need to drop. You need to drop the amount of memory per execution. And if you get any errors on any of the executions, you need to come back down in the memory overclock. So now we have 14.2 out of 32 gigabytes. So 3000 again. This might seem a bit clumsy, but no can do, as this is not the paid version. Oh, it does actually stress the CPU at the same time. So this should be the last one. Yeah, so this is the, because if you open any more of these, it then starts to move things to the page file of the system. So this is enough. So this is pretty much how you overclock the CPU and memory on the Z590 Dark. Pretty much the same process as before on the previous platforms. So if this passes 100% on each of these executions, then it pretty much tells us that the memory configuration is completely stable. But this is obviously dependent on the kit itself, on the CPU's IMC, running 1.45 on the system agent and VCCIO auxiliary, and 1.53 on the memory, just like in the profile, but now just 1918. I didn't change any of the sub timings. But just follow these steps and you should be good to go. The main point I wanted to stress out on this video was the behavior if you decide to go for per core overclocking, and especially per core voltage. So be aware of that situation. So do not do any kind of per core adjustments in the operating system now with EVGA X, or it will change to per core voltage, and then the voltage just goes through the roof without any need. So just be aware. But yeah, so that's pretty much it. If you found this video helpful, then please give me a thumbs up and subscribe to my channel. And thanks for watching one of my overclocking videos once again, and I will see you on the next one.